라이너스는 노션에서 이제 리드 AI 엔지니어로 좀 일하고 있는 분이고요. 그래서 제가 라이너스를 만나게 된 게 이제 디스콰이엇을 처음에 하기 시작하면서 라이너스랑 그냥 이메일을 주고받다가 좀 알게 됐어요. 그때 라이너스는 노션에서 일하기 전이었고 NLP랑 머신러닝이랑 약간 HCI랑 이런 거에 대해서 되게 리서치를 많이 하고 있었고 그거에 대해서 막 글도 많이 쓰고 프로토타이핑도 되게 많이 해갖고 거기서 좀 알게 되고 되게 흥미롭게 생각해서 계속 팔로우업을 하고 있다가 이제 최근 그한 작년 초에 이제 노션에 들어가서 그때도 계속 제가 팔로우업을 하고 있었거든요. 근데 거기서 이제 노션 들어가고 나서 이제 AI 기능들 되게 많이 만드는데 참여를 했다고 해서 이제 한국에서도 이런 AI 개발하고 있는 스타트업들이랑 그리고 뭐 큰 테크 기업들도 이제 많이 하고 있는데 좀 거기 노션에서 경험을 좀 공유해 줄 수 있냐 이런 걸 좀 요청을 해줘 갖고 예, 라이너스랑 오늘 이벤트를 준비하게 되었습니다. 좀 더 설명을 드리면 라이너스는 그 노션에서 Q&A랑 오토필 그리고 AI 라이팅이라는 그 기능들 노션 아마 많이 사용해 보셔서 경험해 보셨을 텐데 저 기능들을 좀 개발을 했고요. 네, 그리고 아까 말씀드린 것처럼 그 전에는 그 인디펜던트 리서처로 이 NLP, HCI 그리고 그 잠재 공간 모델이라고 많이 얘기를 하는 것 같은데 그 저런 쪽으로 좀 리서치를 해 왔던 것 같아요. 근데 저희 라이너스가 이제 프레젠테이션 하기 전에 조금 공유를 드리면 여기 참가하신 분들의 이제 한 30% 분들이 다 개발자셨고 그 외에 또 PM이랑 파운더, 디자이너 이렇게 계셨습니다. 그래서 좀 주로 주신 진짜 많은 질문들을 주셨는데 그 주로 주신 질문 탑 5가 이렇게 되거든요. 그래서 첫 번째는 LLM 최적화 어떻게 하는지, 그리고 두 번째는 AI 제품 개발 프로세스에 대해서 좀 얘기를 해달라. 그리고 AI 쪽으로 UI, UX를 좀 어떻게 발전시켜 나가야 되는지, 그 다음에 AI 아웃풋 정확도, 신뢰도, 그리고 노션에서 AI 기능 앞으로 어떻게 개발을 발전시킬 건지 좀 이게 탑 5였고, 그 외에도 사실 질문이 엄청 많았어요. 막 커리어에 대한 질문도 있었고, 그리고 그냥 이 AI 쪽에 진입하려고 하면 좀 어디서부터 해야 되냐 이런 질문도 많았는데, 근데 오늘 좀 너무 많은 분들이 질문을 주셔갖고 그런 것들은 오늘 다루지는 못할 것 같고 요 탑 5 안에서 좀 다루게 될 것 같습니다. 그래서 지금부터는 이제 제가 라이너스가 시작을 해주면 될 것 같은데요. 라이너스 혹시 스크린 쉐어에서 이제 얘기를 시작해 줄 수 있을까요?
아, 네. 오늘은 기회 주셔서 감사하고요.
음.
제가 한국 사람이긴 한데 한국에서 3살부터 11살까지 한국에 살았는데요. 그 이후로는 계속 미국에 있어서 미국에서 학교 다니고 해서 지금 어 그래서 한국말을 쓸 기회는 별로 없어요. 그래서 한국말로 시도해보고 만약에 좀 너무 어려운 것 같으면 어 영어로 해야 될 부분들은 영어로 하겠습니다. 그리고 지금 한 30분 동안 제가 얘기를 좀 하고 그 뒤에 Q&A로 넘어갈 것 같은데요. 이제 처음에는 이제 제 퍼스널 스토리 어떻게 여기 AI에 관심이 생겼고 시작해서 어떻게 노션에 갔는지 좀 얘기 드리고요. 그다음에 노션에 제가 2023년 1월부터 노션 AI 팀에 있었어요. 처음에 AI 팀이 시작했을 때부터 노션에서 일하고 있는데 그동안 1년 반 동안 그 노션이 AI에 대해서 어떻게 생각하는지 그리고 어프로치가 어떻게 발전했는지 그거에 대해서 말씀드리고 싶고요. 그다음에 마지막에는 이제 그 1년 반 동안 AI 프로덕트를 개발하면서 그 배운 점들 좀 어, 얘기하고 싶습니다. sharing is not turned on.
아,
아,
네. 다시 해봐 주시겠어요?
네, 됐어요, 이제.
네.
제가 노션 시작하기 전부터 제가 대학 생활할 때부터 사이드 프로젝트를 되게 많이 했었어요. 그래서 이 웹사이트에 가보면 여러 가지 여기 이제 사이드 프로젝트를 학교 다닐 때도 그다음에 그 뒤에 일할 때도 여러 가지 처음에는 이제 프론트엔드 웹 디벨롭먼트를 주로 많이 하고요. 그다음에 그 뒤에 프로덕티비티 뭐 노트 앱이라든지 그 투두 리스트 이런 거에 대해서 되게 많이 생각하고 프로토타이핑하고 여러 가지 배우는 겸 또 제가 쓸 수 있는 프로젝트를 만드는 겸 그 프로젝트를 많이 만들었었는데 그 중에 제일 제가 흥미가 생긴 게 프로덕티비티 어떻게 하면은 NLP 하고 머신러닝, 딥러닝을 써서 그 글쓰기나 뭐지 이게 적용되는 뭐 다큐멘터를 읽어야 될 양이 많은
음,
when there's too much to read. 그 reading and writing 글쓰기나 이런 거 할 때 어떻게 NLP를 사용해서 그 시간을 how do you save time? 그래서 2023년, 22년 전에는 여러 가지 시드 스테이지 스타트업에서 많이 일을 했었고요. 주로 웹 디벨롭먼트 하고 그다음에 2022년 1년 동안 이제 그 일을 그만두고 1년 동안 인디펜던트 리서치 하기로 생각해서 그 1년 동안은 뭐 논문 그전엔 제가 AI에 대해서 아는 게 많이 없었어요. 그 대학 생활 때도 AI에는 관심이 없었고 그냥 프로그래밍만 배웠고 해서 22년 동안 뭐 논문도 많이 읽고 그 프로젝트도 많이 배우는 겸 만들어 보고 그다음에 사람들도 많이 만나고 하면서 2022년 동안 AI에 대해서 많이 배운 것 같아요. 많이 연구하고 배우고 하면서 이제 노션 그 22년 한 10월쯤 노션이 처음 AI 라이터를 베타로 그 프로덕트 헌트에 올렸어요. 그래서 기획을 하면서 이제 노션에 AI에 관심이 있던 사람들을 만나게 돼서 그다음에 노션도 이제 AI에 관심이 있고 저도 이제 노션 같은 프로덕티비티 툴에 생각을 많이 했고 그다음에 그런 거에 아, 어떻게 AI를 적용해야 될지 어떻게 NLP를 적용해야 될지 그런 걸 많이 생각하고 있으니까 이제 가서 그런 일을 할 수 있을까 해서 노션에 가게 됐고요. 처음에 제가 그 노션 그 들어가서 시작했을 때는 AI 팀이 딱 네명이었어요. 그 사이먼 그 창업자 중에 하나, 그 다음에 세 명 하나는 머신러닝 엔지니어, 그 다음에 나머지 저하고 나머지 두 명은 그냥 웹 디벨로퍼 백그라운드에 있는 사람이었는데 그때부터 이제 지금은 이제 팀이 한 20명이니까 그 팀도 많이 자랐고 그다음에 그 AI 마켓도 많이 발전한 것 같아서 1년 반 동안 여러 세 가지 프로젝트를 런칭하게 됐는데 그 세 가지가 첫 번째는 이 AI 라이터 그 챗GPT처럼 어떤 문서 안에서 요약해달라 아니면 이런 거를 이렇게 어떻게 다시 에디팅 할 수 있는 그런 프로젝트고요. 그다음에 오토필은 노션 안에 이런 데이터베이스 아니면은 테이블 이런 걸 만들 수 있는데 그 안에서 AI를 쓸 수 있는 방법 이렇게 오토필 만들었고 그다음에 최근에 작년 11월부터 Q&A라고 이제 노션에 있는 모든 인포메이션을 레그 시스템을 사용해서 question answering 할 수 있는 이런 제품이어서 이렇게 세 가지를 다 패키지해서 노션 AI라고 해서 이제 한 달 인당 10불 이런 제품으로 판매했고요. 그다음에 첫 번째 이 라이터는 제가 회사에 시작하기 전부터 좀 준비가 돼 있었는데 23년 2월에 런칭했고요. 그다음에 이건 오토필은 그날 그 해 5월, 그다음에 이건 11월 이렇게 해서 그 몇 달에 한 번씩 이런 새로운 피처를 만들고 있습니다. 그다음에 이 Q&A 이후에는 에이전트라고 알고 계실 수 있는데 그 AI 에이전트 기술에 관심이 지금 되게 많아요. 노션에서도 그렇고 그다음에 그냥 제너럴 인더스트리에서도 에이전트에 되게 집중하고 있는 것 같은데 저희도 그거에 그 에이전트를 사용해서 어떻게 노션 AI가 더 유용해질 수 있는지 그렇게 관련해서 생각을 많이 하고 있습니다. 그다음에 이게 지금 사진을 좀 보여드리면 재밌을 것 같아서 여기가 노션 샌프란시스코에 있는 노션 오피스 1층이고요. 여기는 점심 카페테리아 점심 먹거나 아니면 지금 여기 같이 이벤트 할 때 이렇게 쓰이는 공간이고요. 여기는 노션 뉴욕에도 오피스가 하나 있어요. 저는 뉴욕에 살면서 뉴욕에 근무하고 있는데 여기 노션 뉴욕 이렇게 디자인 잘 돼 있는 이런 공간 여기 뉴욕의 오피스에 점심 먹는 이런데 그다음에 이거는 아이반하고 사이먼 AI가 처음 나왔을 때 여행 갔을 때 처음에 AI를 보고 이거 사용해서 노션에 넣으면 되게 괜찮겠다, 유용하겠다, 재밌겠다 해서 만든 계기가 됐어요. 그래서 그때 그 2013년 말에 찍힌 사진이고요. 그래도 아직 회사가 이제 그 700명 있는 그 작은 회사는 아닌데 그래도 아직 CEO, CTO가 이렇게 그래도 아직 제품 개발에 직접 참여한 이런 회사라서 재밌는 것 같아요. 그다음에 이거는 지금 작년 가을인가? AI 팀 그 미팅의 사진이에요. 해서 그 저 매니저 쪽에 있고 아이반 CEO, CTO 사이먼, 그다음에 여러 가지 프로덕트 매니저하고 프로덕트 매니저 여기, 디자이너 여기 이렇게 앉아서 무슨 아마 Q&A 관련돼서 미팅하고 있는 것 같은데 이렇게 팀은 이렇게 생겼습니다. 여기는 뉴욕 오피스고요. 그다음에 그 AI 프로덕트 개발할 때 그 제일 중요한 그 퀄리티하고 이밸류에이션 이런 거에 관련돼서 질문 많이 하셨는데 그 제가 최근에 이밸류에이션에 대해서 그 강의 한 개는 있어요. 그래서 아마 그거 이렇게 어, 훑어가면서 말씀드리면 괜찮을 것 같아요. 그래서 노션에서 쓰는 이밸류에이션 테크닉은 이렇게 스펙트럼이 이렇게 있어요. 그래서 리서치 쪽으로 이렇게 하면 되겠나? 리서치 이 제품을 만들다 보면은 모델이 처음 나왔을 때는 그 리서치 벤치마크가 제일 많잖아요. 뭐 MMLU나 아니면은 오픈 AI가 모델을 새로 개발했을 때 이런 벤치마크 이런 점수가 나왔다 이렇게 하는데 그거는 사실 실제로 제품 개발에는 별로 제일 유용한 건 아닌 것 같아요. 왜냐하면은 그 이렇게 MMLU나 이런 아카데믹 벤치마크는 다 그 리얼 월드 데이터가 아니잖아요. 실제로 노션의 그 유저들이 아, 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 so in evaluations, there's the spectrum between research benchmarks and real production use. And when OpenAI first releases their models, the benchmarks that they talk about are not based in real world data. They're based on what researchers think are the most useful questions to ask about their models for their understanding of how good their models are. And so when Notion goes to take any of these models and use them in a product, we have to take models that we think might be really good in our use case and compare these models against real world use cases. And as we go from prototype on the left side to production use on the right side, we have to try to build a series of benchmarks or evaluations that test whether the model is going to perform really well in the real world setting. Of course, if we had infinite data and infinite time, the benchmark we would always use is whether users find outputs from a given model high quality. But we can't take every model and evaluate them against real world usage. And so we have a bunch of benchmarks in the middle that are proxies for real world use. So after academic benchmarks, we might try programmatic evaluations where we take output from a model and have deterministic pre-programmed tests like does this output include specific words, specific syntax, specific keywords? Is the output in the right language? After programmatic evals, we might have LLM as a judge evaluations to say, is the output polite? Is the output concise? Is it a good summary? Does the output contain all the key information it needs to contain? Notion also invests heavily in human evaluations. So human eval is anything from generate a bunch of example outputs over a test data set and have humans review and look at the data to end-to-end product tests like deploy the product in a small test set or internally and have humans use the product to see whether the outputs work well within the context of the product itself. And finally, once we ship or launch a product, we have continuous monitoring. So we have various metrics that we watch in production to see whether users are engaging with AI, whether there are errors happening live. We also have metrics that try to estimate how accurate the AI is in answering questions by looking at things like numbers of citations that the AI is generating. In our process, when we started building AI products, one of the big lessons that we learned is that evaluations and data are really the key to how to build really high quality AI products. And data is important because the quality of your evaluations depends heavily on how closely your data matches real-world data that your users are going to input into your model. And at Notion, we think of evaluation as a way for engineers and machine learning researchers to communicate with designers and product managers and users about the ideal behavior of these models. So what does that mean? So let's say Notion is building a summary feature. So a product manager or a designer might tell me, hey, we need to summarize Notion pages. And an engineer might initially say, no problem, let's use this off-the-shelf summarization model, or let's use GPT-4. And then later we'll realize, actually, this model, when we ask it to summarize things, it's missing some key points, and the outputs feel very boring. And then I might say, oh, what if we fine-tune this model on these summaries that I got from our data? And then the designer might then say, oh, it didn't work for these inputs. And so there's a lot of back and forth. And what we're ultimately trying to do is to agree on a standard set of behaviors, agree on what makes a good summary and what are some example demonstrations of summaries that we like and summaries that we don't like. And so between engineers and designers, we're trying to agree on a common description of the task that we want the AI to perform. And in summaries, as an example, academic benchmarks, which are on the left, CNN, Daily Mail, Archive, these benchmarks all are interesting to researchers because they measure specific qualities that they're interested in, like long context performance or summaries of dialogue. But none of these examples of data in any of these data sets match what Notion users want to use Notion for. So research users might say, we are interested in summaries of research papers and long documents and conversations. But for Notion summaries need to mostly be about meetings and reports and updates written by people working in a team and notifications of what's going on. And so if Notion wants to make a good summary model, we need to build our own data set and our own evaluations for what kinds of documents we expect our model to be able to deal with. And once we have this mindset, when someone comes to me and asks to summarize Notion pages, I could then say, instead of jumping straight to a model, I can say, what makes a good summary? What kinds of pages are we summarizing? And then they might say, we need to summarize meeting notes, what pages, these languages. And then based on that, I can start building a data set that I can use to test any given model for how well they perform. So with this in mind, with viewing data sets and evaluations as a way for engineers to communicate with designers, here is Notion's current process for how we go from a new use case to a model that we think we can ship. We start off by defining a use case. So let's say for Q&A as an example. Q&A's use case is people have questions about information they have inside Notion, and they want to ask that question. And if the answer exists inside Notion, they want to get good answers based on it. If the answer doesn't exist inside Notion, they want the model to reliably tell them the answer doesn't exist rather than making something up. So just based on that, the first thing we do is gather a bunch of inputs. We gather, in this case, there are two inputs to the model. So there's the input of the question that the user asks. It may be questions about facts. It may be a lot of times in the real world, users ask questions that we don't expect. So they might ask, what are the most recent documents that I read? They might ask, how do you use Notion? They might ask questions about Notion. They might ask, like, what are documents that are written by this person? There are a lot of questions that we don't support. There are also a lot of questions that we do support, like, where's the document about our recent product launch? Or what is our policy on XYZ? And so we gather a bunch of inputs that we think are express desired behavior, as well as express behavior that we think are unexpected things that we want to still behave correctly for. And using those inputs, we can build a prototype system. So this prototype system is usually taking the most capable model that we have. Currently, it tends to be GPT-4o or Claude Sonnet, and build a prototype that we can use to deploy internally. Notion tests a lot of products internally. Notion internally runs on Notion. So a lot of processes inside the company use Notion. to manage our internal communications. So we build a prototype, we deploy it internally, and then based on just internal usage among the 700 people that we have in the company, we can collect all of the ways that the models fail. And I'll talk about that in a bit. But once we collect a bunch of failures of bad outputs, we can use that to improve our data set of example inputs and example failure cases. And you can use that to iterate on the model. Iterating on the model might involve prompting. It might involve fine-tuning the model. It might involve adding a second stage to a pipeline of a language model. But through this process, we iterate in dev, and when we think we fixed the issues that we are aware of, we deploy it again, we collect more failures, and we keep looping this until we think that the quality of outputs inside our internal environment matches what we feel like we would be proud to ship. And at some point, we will roll out the product or release it publicly, sometimes to a small number of people in a beta program, and we'll monitor both feedback from the users themselves as well as automatically monitored signals in our logging. I want to focus on how we collect failures when we test products internally.
Could we do a quick Q&A in the meantime, or should we wait for questions till the end?
Linus, are you okay with people asking in the middle? Yeah.
So you said that after you defined your use cases, your target use cases, you try to come up with a data set that you would evaluate your models against. That seems like a big task. First, because just collecting of the data.
So you're curious about the initial process for gathering the first examples?
Yeah, how you set up your initial data set and how you determine whether the data set that you've collected will actually serve as a good proxy to the actual use cases within Notion, because that's going to be the criteria that you, or that's going to be the measurement stick that you measure all your models with.
Yeah, I'd say there are two main ways that we do this. The first is sometimes we'll just build the prototype and use it within the team, within the AI team of like 20 people. And just by trying to use it, by using the feature, we can generate a bunch of inputs and examples that we think are likely use cases. And this initial set doesn't have to perfectly represent the real world use case, because the whole point of this loop in the middle is that based on the initial inputs, we build something, and then over time, as we use it internally within the company, and as you roll it out to the wider world, we're going to progressively get more and more realistic data. The other way we build the initial input set sometimes is sometimes we'll have a really clear description of what kinds of failure cases we can imagine the model having. So when we built support for foreign languages into Q&A, the data set that we wanted was quite clear, which was we want the model to do the same thing that Q&A already does, but we want to do it for foreign languages. And so a lot of that initial data set was taking a part of our existing data set of English Q&A questions and answers, finding documents like that in foreign languages, and then translating questions into other languages. But the initial data set it's not super important that the initial data set is perfectly realistic, because if it's not, then you're going to hopefully find out over the course of testing your product internally or externally by collecting failures, which is what I was going to talk about. So maybe I'll go into that. Once we have some prototype that we're using internally or we've rolled out externally to a small number of users, we'll collect bad output examples in a bunch of different ways. The one way is by continuous evaluations and logs. And so any evaluation that we can run programmatically without an AI, things like evaluations based on keywords or based on the structure of the output, will just run on every single inference that AI inference that we have. And we'll log it all to one of our logging services that we have. And any output that failed that we already know has failed, we can go back and look at. And so logging is very important for us. Second, we obviously interview our users both externally, and we talk to a lot of users internally, users of Notion within Notion. And based on that, we can try to understand how people actually use the features that we want to build compared to what we thought people were going to use it for. And sometimes we might find surprising use cases. So when we built autofill, one of the things we learned when we deployed it internally is that a lot of our employees used it to translate. And so we then use that to build a version of autofill that was built for translation that worked well in translation. A lot of AI products have thumbs up, thumbs down feedback buttons. This is actually not very useful for us. We do have it because it sometimes lets us catch examples that we otherwise would not have caught with other use cases, because there are rare examples that only pop up once in a while that we can only catch from production. But the reason that it's not useful is because very few users actually bother to click the thumbs up, thumbs down buttons. And even Notion at our scale doesn't have enough traffic such that we have enough thumbs up, thumbs down feedback coming in that we can make any kind of like wide generalizations based on what kind of outputs get thumbs down. So we do have it, but it's not our most important source. And then internally, we do some adversarial testing, which means we have some of our data people tried to use the product and tried to give the model intentionally unexpected inputs that we think might make the model fail or we think might be really hard for the model. And this helps us get a good sense of the capability envelope of the model, where the model performs well, where the model starts breaking down. And so we always have a good idea of where the models perform really well based on real usage, and also where the model starts performing really poorly based on this adversarial testing. Of all of these techniques, I think evaluation and logs are the most important. And so one of our biggest takeaways in the last year and a half of building these products was this third point right here, which is that one of the most important things you can do technically if you're building AI products with language models is to build comprehensive, fully replayable logging, which lets you take a bad output from the wild, from real production usage or from your internal testing, and based on that single example, fully reconstruct the pipeline that you were using and fully debug it. So that so what that means is, if one of our designers or product people or salespeople say, this user tried this input and it failed, I can take that input, I can search our log for exactly what went into the model and what the model output, and then I can take that log, bring it into my development environment, rerun it, and test it on new prompts or new models until I can get the system to do the right thing in that use case. In that case, and then once I do that, I'll then add that example to our testing data set so that we don't regress on that particular example going forward. So logging is really important. Two other big lessons that we learned are, one is it's important to use your product as early as possible and often to refine your understanding of the task. A lot of people talk about what defensibility or unique differentiation in AI looks like. And people often try to say a source of differentiation in AI is how good your model is. But I think, especially if you're building applications for end users on top of AI and not just building models as your product, then the most important advantage that your team has is that your team needs to understand the task that the AI needs to perform better than anybody else. What I mean by that is your team needs to know why the task is hard, what are the right ways to break down the task so that it's easy for the AI, what are the ways that the model messes up frequently, what is the model naturally good at and what is it bad at, and how can you get the model, why does the model struggle with this task when it does struggle? And the best way you can develop a deep understanding of the task and why it's difficult is if you frequently use your product and look at the outputs and try to understand why the model messed up in a particular use case. So we do a lot of that. Another point that we learned is that when you sit down to describe the kind of product you want to build, not only do you need to figure out what your interface is going to look like and what the functionality is going to be, but also define the evaluation and define what your standard of a good output is as a part of the product spec. This goes back to using evals as a communication point between product people and engineers and researchers. When I sit down with a designer to talk about how a particular AI feature should perform, one of the things I want to focus on is what do you define as a good output? What are the ways that we can build examples of that into the evaluation that we're going to be using? Let's see. If you come from a traditional machine learning background, a lot of lessons in traditional machine learning carry over into working with LLMs. I think more insights from traditional machine learning carries over into generative AI machine and language models than you would expect. But one key difference is that in machine learning, you deal with your training data set in large volumes. You say, here's my whole data set. And if you want to study the data set and what goes into it, you will frequently look at clusters of the data set or large subsets of the data set. But for language models, what we do much more often is we'll look at individual failure cases, individual examples, and individual logs. And so that requires a slightly different set of tools and a slightly different kind of workflow. And so evaluations, unlike in academic research, evaluations and data sets are not your source of truth. Your users and what they do in the real world are your source of truth. And you can build for them by making sure that your evaluations best reflect what real world use is based on internal usage or external usage, and how well your model performs on your evaluations. And I think really the hardest challenge here is to make sure that your evaluations cover all of the full space of inputs that you really hope your system works well for. I think it requires constant work and vigilance to make sure that your evaluations are as good as they can be, and that you are scoring the outputs and judging the outputs with as much attention to detail as possible. One thing that teams may be tempted to do when they start out is they may say, we don't want to spend that much time evaluating inputs manually. I want to build a bunch of automated pipelines to automatically look at outputs and evaluate them and score them. And while that's something that saves time down the line when you have lots of data, I think initially it pays off to have humans on your team, real engineers, look at individual outputs so that they can build up this understanding of the task, so that they can understand how the models fail and what the model's tendencies are for a particular task. That's the main part of this talk. Besides that, I think the last thing that's really important for AI teams, I think, is who's on your team. There are two main ways that I've seen AI teams, good AI teams, come together in companies of Notion's size or larger, and also in smaller companies. The first way is you have a machine learning team that you repurpose into an AI or a language modeling team. So you have machine learning engineers, or maybe you hire new machine learning engineers, and you say, instead of training models and deploying these small models, you're going to work with language model APIs. And I think that tends to result in a team that's very focused on data, focused on evaluations, and focused on benchmarks and scoring well on benchmarks. And the thing you have to watch out for with a team of ML background people is that you have to focus as much as much of the effort on making sure that your evaluations are reflective of what your users actually want to do, making sure that your evaluations match the real world expectations. The other way that I've seen AI teams come together is if your company doesn't have an existing ML team, you could take your existing engineers and have them learn or upskill on how to use the OpenAI API or other language model APIs. That's what Notion did. So Notion never had an AI team before I joined. And then a part of me joining was starting up this new AI team. And initially, the AI team was mostly non-ML people. Today, we have maybe 3 or 4 ML people, but it's still majority web engineers. And the strength that this kind of team has is that you're really, really familiar with how to understand your users and how to test in the real world and how your experience is. But the thing that I think Notion took a long time to learn is the importance of rigorous evaluations and the importance of building up really good data sets, having good hygiene and good workflows around the data sets to make sure that our data sets have only the highest quality data points that we can gather, and that we're confident that if an example is in our data set, that it demonstrates a kind of a perfect ideal example of what a model output should be. And so depending on where you are currently, and if you're thinking about building an AI team, those are two approaches that I've found viable in other companies. I think that's it. We can go to Q&A.
How are you doing?
I'm good.
Okay, thank you so much for sharing your insights.
Of course. 또 질문 있으시면 이메일이나 링크드인, 트위터로도 연락해 주세요.